All right, so last law we're going to look at for solving triangles is the law of cosines. And when we did law of sines, that's LOS, law of sines, we solved these three types. Angle, side, angle. Side, side, angle. That was the end of last week. And yesterday, actually, side, side angle was the one we did yesterday. Remember, with side, side angle, you can get 0, 1, or 2 solutions. What are the two types of triangles that are not up there?
Side, side, side.
Side, side, side.
And side, angle, side.
Side, angle, side, yes. In both of those cases, if this was your table, if you knew a side, and a side, do you have a full row?
No.
No. Okay, and then if you were doing side, angle, side, you would have something like that. Is there a full row there? Because you don't have a full row. All you have is partial rows. You can't use law of sines on those problems. Okay, so that's where law of cosines comes in. So this is an example of a side angle side. Again, SAS is just referring to the information you're given and the placement. Two sides and an angle between them. When I say an angle between two sides, it's where the two sides meet. So it's right between the two sides. Okay. And the other type is side, side, side. And that one's pretty obvious. In a side, 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 you're given all the sides. Okay. Sometimes people ask about like angle, angle, angle. That's impossible. You can't do angle, angle, angle. Because that's like if I said to you, I'm thinking of like an equilateral triangle. If I told you all my angles are 60, and I said how big is each side, you wouldn't know. Could be 5, 5, 5. Could be 30, 30, 30. You always have to have at least one side, no matter what type you're doing. So this one has 3 sides, 2 sides, 1 side, 2 sides, 1 side. But you're always going to have one side. So any questions on the two types we're going to look at today? All right. So what we'll do is we don't go through the proof of the law of cosines, but I think you'll recognize part of the formula. It's something you've seen before. So let me write down the law of cosines. All right, so it's c squared equals a squared plus b squared. That's not the whole thing, but what is it? What does the beginning of it look like?
Pythagorean theorem.
Yeah, it looks like the Pythagorean theorem, and that is how you prove it. You use the Pythagorean theorem to get this formula. So it starts out c squared equals a squared plus b squared minus twice the product of the two letters you wrote down immediately before it. And the last thing is the cosine, and you fill in the angle across from the letter you started with. What angle is always across from C? Gamma.
That's great.
So it's like it's the Pythagorean theorem, but then there's this minus 2ab cosine on the end. It's like an adjustment because the angle isn't 90. Now, you don't see this part in Pythagorean theorem. And that's because when you do Pythagorean theorem, the angle across from C is always how much?
90.
It's always 90. Well, fill 90 in for gamma. Watch what happens. What's the cosine of 90? 0. So when you're using Pythagorean theorem, this angle is 90. Cosine of 90 is 0. And what's 0 times anything?
0.
0. So this whole part cancels out when you have an angle of 90. That's why you don't see it in Pythagorean theorem. When the angle is not 90, that part is not 0, and then it becomes important. All right, so that's the first way you can write it. And what's really more important there is the pattern, okay? Not necessarily the letters, but the pattern of the letters. So let's say we started with b squared. We could also start with a squared. It's going to follow the same pattern. One side squared equals the sum of the other two that you didn't use there, minus twice the 2 that came before it, and then cosine of the angle across from what you started. So what do you think would come right after the equal sign if I start with b squared?
A squared minus c squared.
A squared, yep, follow the same pattern though. The plus, the minus, the 2, and the cosine all stay the same. So what would go here?
Oh, a squared.
Yep.
Negative c squared.
Plus c squared. You're not rearranging the first one. You're just writing it with different letters. Okay, so b squared equals a squared plus c squared.
Oh.
And then what would come after it?
Minus 2ac.
Minus 2ac. And cosine of theta. Yep. That's not a different formula. It's exactly the same formula. You just wrote it with different letters. Right? So you could do x squared equals y squared plus z squared minus 2yz. It's the same thing. So just practicing writing it different ways. How about if you started with a squared?
B squared plus C squared.
So one side squared equals the sum of the other 2 you did not use minus
2 base
2 times the sides that came right before it
Alpha.
times the cosine of the angle across from the letter you started with. So it's important to understand the pattern because I might not label the sides A, B, and C. I might not put any labels on the problem. So then you can either put your own labels or just try to remember the pattern of the formula, not the exact letters that it uses. Okay, so that's the law of cosines. So notice every version of the formula has every side in it. There's an A, a B, and a C in all 3 ways you can write it. So let's see if we can solve this one. Okay, so we have A, B, and gamma. How can we tell from the table if that's law of sines or law of cosines?
There's not a full row. though.
There's not a full row, so that means what? It means it's law of cosines. If you forget that, you can always draw it out. A, B, C, alpha, beta, gamma. Circle what you know. You know A, you know B, and you know gamma. What kind of triangle is that using the 3 letters?
Side
Side
angle.
and side.
Side, angle, side. And we just wrote down that that's one of the types you use on law of cosines. Okay, so when you are solving the law of cosines and you have a side angle side problem, you have to find the side you're missing first. You don't have any choice. You have to find the side first. So, which version of the law of cosines am I going to use to find C? Which one?
First one.
Yeah, I have to use the first one because I'm already missing the C. Okay? I can't be missing anything else. If you pick the second one, you need to know C, which you don't, and you need to know beta, which you don't. That's a problem. You can't be missing 2 things. You said, well, let me try the last one. Well, you don't know C, and you don't know alpha, so don't pick out. Look at the top. You know A, you know B, you know A, you know B, and you know gamma. You have everything on the right-hand side. So that's the one to use. So we're going to fill it all in. Okay, so C squared. And we'll do a little bit as we go. What's A squared? 16. How about B squared?
49.
49. Minus 2 times A times B. Well, 2 times A is how much? 8. And then 8 times 7?
56.
56. And the last thing is the cosine of the angle across from the letter you started with, 42. All right, now we just have to simplify that. Okay, I have like terms I can combine. What are my like terms that I can combine with addition?
16 and 49.
16 and 49. Don't do minus 56 because that has to be multiplied first, okay, if you follow PEMDAS. What's 16 plus 49? 65. Now, what I would do at this point, I wouldn't worry about doing anything else on the right-hand side because there's nothing else you can do without rounding. What we want now is to get C by itself. What do you have to do on each side to get C by itself?
Take the square root.
Yep, just take the square root on both sides. And if you type in this whole thing in one step, you're not going to do any rounding until you get to the final answer. Any questions on how we got to that step? All right, just type it in. Okay, so square root of 65 minus 56 cosine 42. Okay, you should have gotten 4.836. If you got 4.836, then you did it right.
Is that going to be a plus or minus?
No, because you can't have a negative sign. Everything's always just a positive answer in solving triangles.
Should we get our calculators?
Yeah, I can get those. Sorry about that. Okay, so for C, we got 4.836. Now, let's look back at the diagram I drew for a second, because now we have more information. So it might be more than just a side angle side problem. Here's the diagram. Now we know that too. Besides side angle side, with that extra information, what else is it now?
Side, side, side.
Yep, it is also a side, side, side. And it's one more type.
Side, side angle.
It is side, side angle, or side, side angle, whichever way you want to look at it. These first two use which law?
Cosines.
This is the law of cosines. What about that bottom one? That would be law of sines. But what can happen when you try to solve side, side angle?
You could get it on one solution.
Yeah, we can get the no solution, one solution, two solution. So I don't want to get into worrying about that. Law of cosines will automatically figure out what the answer is supposed to be for me. All right, so even though you do have more information, and technically you can solve this with law of sines if you do it carefully. It's better to just stick with law of cosines to finish it. So that's what I'll do. Any question on that? Okay, so that's how you find the side. pretty much when you find a side, all the numbers are on one side for you automatically, and the variable you're solving for is pretty much by itself, except for the square root. That's the only thing you have to do to get the letter alone. Right. Now let's solve for an angle. Okay, do we want to solve for alpha or beta? Alpha. Okay, out of the three versions here, which one is going to solve for alpha? Yeah, so we need the third one. Find C. Now we'll find alpha. Okay, so let's start writing it down. So a squared. So a squared is how much? 16. Already a difference right off the bat. You don't have a letter on the left side this time. You have a number. So a squared. B squared is how much? 49. Now I need c squared. I never figured that out, but can somebody tell me what that comes out to?
It's about 23.386.
23.386?
387.
387.
387 if you round it?
Yeah.
Okay. So that's a squared, b squared, c squared. Now I need 2bc. Well, let's do 2 times b first. What's 2 times b? So 14 times c. I need 14 times 4.836.
67.704.
67,704 you said? Okay, so that's 2bc cosine alpha. Okay. So this time, when you're finding an angle, the variable is on the right. So we need to move everything that's not the variable over to the left. All right. What are my like terms I can combine first?
49 and 23.3 is that what?
Yep, you can add up 49 and 23. So that's going to give me 72.387. Now you can't minus 67 from that because you have to multiply by cosine alpha first. So the next step, if it's confusing with the trig in there, then think of it as an equation without trig. Think of it as like 16. I'm just going to make the numbers simple. Equals 72 minus 67 times something you don't know. That's all cosine is. It's something we don't know. So whatever your next step would be here, it's exactly the same as the next step above. So what would be your next, what do you think your next step would be?
Subtract 72 and 3 from both sides.
Yep, subtract 72 from both sides. I'm just going to move that over there. Okay, so minus 72 and minus 72. Okay, that's gone. Now I need 16 minus 72.387.
Negative 56.387.
Negative 56.317?
387.
387. It's okay you have a negative here. That doesn't matter because we're not done yet. When we're done, we shouldn't get a negative because angles can't be negative in triangles. Okay. All right. Now, how would we get the negative 67 on the other side?
Divide it.
Right, we divide it. So you're multiplying. The opposite is dividing. Divide by negative 67. Divide by negative 67. So this is all gone. And what do you have left on the right side now? Cosine alpha. And how about on the left side? Well, actually, you know what? I wouldn't even do it out. We know those negatives are going to cancel. Just leave it like that. 56,387, 67,704. I didn't do it out because I didn't want to round again, and so I'll just leave it. And what's my last step?
Inverse cosine.
Yep, take the inverse cosine on each side. Okay, that's how you find an angle. So we just have to type that in. Inverse cosine, 56,387, 67,704. So you should have got about 33.608. Yeah, 33,608. Now, once you have 5 out of 6 things, especially when the only thing left is an angle, it's pretty straightforward to finish. How would we get beta?
42 plus 1,608 minus 1.
Yep, just minus that all from 180. So 82 plus 8. So that third angle should be 104.392. And that's law of cosines. So the first step, we found a side. In the second step, we found an angle. They are a little different. When you're finding an angle, you have to use inverse trig. When you're finding a side, you don't. You have to use a square root. But that's pretty much how every law of cosines problem ends up. Just like that. All right, any question on that? Yeah.
If you've got an imaginary number inside there, does that mean that it has no solution?
The side angle side, it's impossible to have a no solution. You could literally give me any numbers you could make up,
From the
and it would always work. I mean, you couldn't make up negative numbers because you can't have negative sides. But any positive number, another positive number, and a positive angle, you'll always get an answer. That's the nice thing about side angle side. You don't have to worry about no solution. All right, let's look at side, side, side. Do we have a full row? No. So that means it has to be law of cosines. Now, with side, 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 you do have to do one quick check to see if it's a no solution. In a triangle, any two sides added together have to be bigger than the third. So if you check these, is 9 plus 7 bigger than 5?
Yes.
Yeah. Is 7 plus 5 bigger than 9?
Yes.
Okay. How about 9 plus 5 bigger than 7?
Yes.
Okay, then we're good. If I give you sides of like 1, 1, and 1,000, you can't make a triangle with those. Because you have one really, really long side, and then you have these little two short sides on the end. They're never going to connect. Okay, so any two sides added together have to be bigger than the third. Not equal. So if I gave you sides of like 3, 3, 6, you can't make a triangle with a 3, a 3, and a 6. They won't come together. It's impossible. You could do 3, 3, 5. That'd be okay. And if it was 3, and if you had two sides that are the same, that's actually nice because it's isosceles. Then you know you have two angles that are the same. But when it's scaling, you got all the sides different, all the angles are going to be different. Okay, so in side, 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 you can find any angle you want first. Doesn't matter. Okay, we already did law of cosines with an alpha, so let's try it with either beta or gamma. Beta? Okay, so let's find beta. So that's b squared, a squared, c squared, 2ac, cosine beta. Okay, what's b squared?
49,
49. A squared?
81,
C squared?
25.
That's the nice thing with side, side, side. Usually all the sides are nice numbers. So at least to start the problem, the arithmetic is pretty easy. 2 times A times C. Well, let's do 2 times C first, because that's easier. What's 2 times C? 10 times 9. 90. Okay. What would I do first on the right-hand side? On like terms. What's 81 plus 25? Yeah, 106. Okay, next step.
Subtract 106 from the side.
Subtract 106. That's gone. Let's take that in. 49 minus 106, negative 57. What's the next thing that we move to the left? Yep, divide by negative 90. That cancels the negative and the 90 on that side. Also cancels the negatives on that side. And now all you have left is cosine beta. How do you get rid of cosine?
Inverse cosine.
Inverse cosine. You type that in and that's your answer. That's pretty much how you find a side. You can do it in about maybe five steps. Depends how much arithmetic you do in one step all at once. Right, does anybody have what that comes out to?
50.704.
50.704? Okay. Now, you would have to do law of cosines one more time to either get alpha or gamma. It doesn't matter which one, because you're not going to use this 50.704 at all. You don't need that. You just need the three sides. Does anyone want me to go through same steps again for alpha or gamma?
Alpha.
For alpha? Okay, you can do alpha. So first thing I do is I write the formula so I don't have to think about what it is. A squared b squared plus c squared. Cosine alpha. Okay, so I don't have to scroll up. I'm going to ask you guys. What's a squared?
81.
81. B squared?
49.
25. And c squared?
B squared be 49.
49. Okay.
C is 25.
C squared is 25. And now I need 2 times 7 times 5. 70. Cosine alpha. Okay. Combine like terms. What's 49 plus 25?
74.
70 what?
4.
74. Can I do 70 minus 74?
No.
Or 74 minus 70? No, can't do that. Bring the 74 to the other side. Okay, 81 minus 74, 7. Okay, now we got 2 steps left. What would you do as your second to last step? Divide by, what is it? Negative 70. And your last step, we can do it at the same time. Inverse cosine. There you go. That's how you do it. Yeah.
Are you allowed to like use both? Like say you use law of cosine to get like data or something, like to get like alpha next, could you use law of sines?
Technically, you could. Yeah, if you're very careful. Yeah, you could. I usually, if I start with law of cosines, that's how I finish it.
Alright.
But you could. Okay. That's side, side, side. Any question on that? Okay, so last thing we're going to look at is an application with these two triangles, which is area. What's the formula for area of a triangle? One half what? Yeah, the area is 1/2 base times height. Okay, I'm not going to go through the diagram, but I do want you to have the formula. So don't worry about that. Now, in order to use that formula, what are the two things you have to know about the triangle? The base and the height. Now, if you had a triangle like this, let's say this was 40 degrees, and 9. Does any number up there represent the base?
Yeah.
Sure. Which number?
Nothing.
Yeah, we could let 9 be the base. Is there a number up there that represents the height?
No.
No. So when you have side, angle, side, which is one of the kinds of law of cosines problems we're doing, usually you don't have the height. So I'm going to give you a formula that will allow you to find the height in this kind of problem. I'll give you the formula. So the area of a triangle is half the product of 2 of the sides in the triangle. So it has a half in it, kind of like 1/2 base times height, times the sine of the angle between the sides. So let's see what that would look like if we use some letters and stuff. Let's apply that to that triangle. 1/2 the product of 2 of the sides. Okay? All right. So pick 2 of the sides. It doesn't matter. Any 2.
A and B.
A and B. Now the next thing matters. 1/2 the product of 2 of the sides times the sine of the angle between those sides. What's the angle between A and B? Gamma. Yep. Let's try it again. Pick 2 different sides.
B and C.
B and C. So give you the same answer. 1/2 the product of 2 of the sides times the sine of, what's the angle between the sides? Alpha. Yeah, I'm not going to write it every way you can. As long as you remember this idea, that's the important thing. And that's how you can find the area of a side angle side triangle. The proof of that is pretty easy, but we're not going to go through that. Now, this time you don't really have any choices. You pretty much have to use the information they gave you. You don't have any other numbers to use, so you're going to use all 3 of them. Anyone think they can tell me what the formula will look like using the information in that triangle? It's gonna look like this, but you're not gonna have any letters. You're gonna have all numbers. Yeah?
Would have 3, 12, 7, 5.
Sine 105. Okay. And what's 3 times 12?
56.
And then times a half. So the area of this triangle is 18 times the sine of 105. 18 sine 105. Now when you write area how many dimensions does area have? Well, one-dimensional is length. Area is two-dimensional. So on the end of your answer, what should you put?
Square.
Yeah, square feet, square inches. We don't know what it is this time. 17.387. Does anyone know what you put when you don't know what the unit is?
U.
Yeah, we'll just put square units. And that's how you can find the area of a side angle side triangle. Now, the last triangle. What's the last triangle that we did with law of cosines? We did a side, side, side. So if I gave you 3, 5, 6, first make sure that that would even work. Yeah. What's missing in this formula, in this triangle, to be able to use this concept? You're missing an angle. Okay. How could you figure which angle do you need?
Any.
Yeah, any of them. You just need one of them. And how can you figure out one of these angles? You can do law of cosines exactly like we did right here. When you have three sides, you can use law of cosines to get an angle. And then once you have an angle, you can use the formula I just showed you. Now that works, but that's the long way to do it. Okay, there's a shortcut that allows you to find the area, but you don't need the angle. Okay, and this is called Heron's formula. The other formula doesn't have a name that I know of, but this one does. So Heron's formula is how you can find the area of a triangle when you know all three sides. But remember, it's not needed. You could just use law of cosines, figure out an angle, and do it the way I showed you already. But this is a lot shorter. So it says right next to it, the area of a triangle with sides A, B, and C. So that's what the A, B, and C are. But what letters in that formula we haven't seen before?
S.
S. Well, that's S. It's half of A plus B plus C. What is that really giving you? Well, half the perimeter, yeah. So half the perimeter is called the semi-perimeter. That's where the S comes from. So it's the semi-perimeter. So you just add up all the sides and then take half of it. So this formula basically takes all the trig right out of it. There's no sines or cosines or anything. Just straight algebra to find the area.
Thanks, Aaron.
What's that?
Thanks, Aaron.
Yeah, Aaron helped us. So, you know what? Let's I'm gonna go back to the problem we did earlier. The 975. Does everybody have that formula? Okay. Let's find the area of the side, side, side problem we just did, because we already found an angle with law of cosines. Okay, so I'm just going to do this off to the side. I'm only doing it because I already have an angle, so it's not going to take long. And then we'll do it with Heron's formula. So think of your triangle. Here's A, here's B, here's C, here's A, B, C. Beta would be up here. Alpha would be over here. And C, oh, C we know is 5. Sorry. C is 5. Okay, so how would I write the area using these numbers?
Nine times 5.
1/2 9 times 5 times what?
The sin of 50.704 degrees.
5704. Okay, so that's the formula we learned before. We can use it because we know an angle. So let's try it. 9 times 5 is how much? And then half of 45?
22.5.
So 22.5 times the sine of 50.704. Okay, so 17,412. Okay, so just remember that number for a minute. 17,412. Now, let's try to find the area of that same triangle, 975. But let's pretend we didn't already do law of cosines and we don't know any of the angles. Okay, so we're going to use Hager's formula. All right, so let's start with the semi-perimeter. What's 9 plus 7? 16, and then plus 5, and then half of that. Okay, so there's your semi-perimeter. So it's the square root of s, and then it's times s minus every side. Doesn't matter the order you do it. So square root of s. And now we need s minus every side. What's s minus a? 1.5. What's s minus b? 3.5. And what's s minus c? 5.5. So this should come out to exactly what we got before, 17,412. Let's see. 10.5, 1.5, 3.5, 5.5. Exactly what we got before. So nice thing about Heron's formula is it lets you find the area right away. You don't have to find any angles. If you already have an angle, well, then I just use the first formula I gave you.
Why isn't it completely exact?
Because the 704 is rounded.
Oh,
If we had more decimals in the 704, we'd have a better, even closer answer.
So ladder's more correct.
What's that?
Ladder's more correct.
Yeah, this is exact. There was no rounding to get this bottom answer at all. Everything there is exact. Yep. And it's easier to not do any rounding in this formula because you don't do any trig. You just have to take a square root. Okay. Any question on that? Okay, so that finishes up the triangle stuff. Let me just double check. I think that's okay. Okay, remember, you could have a side with no solution. Check that the sides added up are bigger than the third.